Hello friends, today in this video we are going to discuss about non-linear differential equation if it is solvable for p, x and y. So let us see differential equation of first order and higher degree differential equation which is solvable for p, y and x. Higher degree is there, so it is going to be what? Exactly non-linear. The most general form of the differential equation first order and the nth degree differential equation can be expressed in this way. dy by dx raised to power n plus p1 dy by dx raised to n minus 1 plus p2 dy by dx raised to n minus 2 and so n plus pn is equal to 0, where p1, p2 and pn minus 1 are functions of x and y only. If we denote dy by dx is equal to p, then our differential equation is going to be p raised to n plus p1 p raised to n minus 1 plus p2 p raised to n minus 2 plus and so on. So this is what exactly differential equation, but we can say it is the equation in p form. So we can say f of x, y and p is equal to 0. So this is nothing but our standard form. We will keep in mind that whenever the examiner asks solve for x, solve for y or solve for p, so they may ask in different ways. So it is difficult to solve this type of equation in its most general form, but in several cases can be solved by reducing it to first order and first degree equation by solving it is for p, x and y. So let us see first one, differential equation solvable for p. If LHS of equation number 1, that means this is the right hand side 0 and this is what exactly LHS side. So LHS side, which is the nth degree polynomial in p and that can be resolved in n linear factors, then it is going to be formed this one, p minus f1, p minus f2 and p minus fn is equal to 0. So these are nth factors we can say, but you can assume that p is equal fi xy, I is nothing but 1, 2 and so on. So in that case dy by dx is going to be fi xy because p is what exactly dy by dx. Now this is the standard form, and solving this n equation, what we get fi xy c is equal to 0. If we assume that here fi is equal 1, so it is going to be f1, so we can say f1 xy c is equal to 0 and that will be the solution. Here thus the general solution of this f of xy p is equal to 0 is given by f1 xyc is equal to 0, f2 xyc is equal to 0 and last fn xyc is equal to 0. And the product of these functions is going to be what exactly whatever we have the given differential equation, that is going to be solution. So let us see first question, dy by dx minus dx by dy is equal x divided by y minus y by x. So what we have to do first, we have to assume that dy by dx is equal to. So therefore equation number 1 takes the form p minus, but this can be written as what? 1 divided by dy divided by x. Okay, so in that case 1 divided by, that is p, is equal x divided by y minus y divided by x. But when we take this by LCM, so p square minus 1 is equal x divided by y minus y divided by x into p. But here you can verify p square and plus p minus 1 is equal to 0. So here you can write in this way. Now just take p from common from this one, as well as again you can. So what we have, p plus y by x, that will be the remainder. But I want this one as here. But before that, let us assume that minus will common, x by y into p plus 1 is equal to 0. But here you can observe that p plus y by x, that is we want. That means I want coefficient of p is equal 1. So what I have to take x by y as a common. So it is going to be p plus y divided by x is equal to 0. Now we can say this is a common, and then we have p minus x by y. So we have the two factors. So let us consider first one on the left hand side and this is on the right hand side. This is the second one. So here we can observe that after solving this linear form, we get the solution yx is equal to c, and this can be written as yx minus c is equal to 0. On the right hand side, p minus xy is equal to 0. So in that case what we can say, again this is what exactly based on the variable separable, we can say that x square minus y square is minus c is equal 0. So therefore the solution to given differential equation is going to be product of these two functions, and that is what we have. And this is the another question. X square divided by dx raised to power 2 plus xy divided by dx minus 6 times y square is equal 0. Here divided by dx is equal p. So just assume that x square p square plus xy p minus 6y square is equal 0. Again, product of this first and last is going to be minus 6x square y square p square. So we have to factorize it so that its product are addition and as well as addition subtraction is going to be xyp. So 3 into 2, that is the 6 x square p square y square. So when we take its product, these two numbers, so it is going to be exactly product of first and last. Now you can apply here xy common, so xy plus 3y, and the same argument 2y common, so we had this one. Again this is common, so we have 2xp minus 2y is equal 0. But here xp plus 3y is equal 0, this is first factor and this is the second. But after integrating using the variable separable method, we can find its solution, and that is going to be general solution. And this is as a homework, so you may try to solve yourself. Differential equation solvable for y. This is solvable for y. So for f of xy p is equal 0, if this equation can be written in the form y is equal f of xp, that means we want y in terms of x and p, then it is solvable for p. So now first what we have to concentrate, derivative, differentiating with respect to x. So dy by dx is equal del f by del x plus del f by del p into del dp by dx. And since dy by dx is nothing but p, so then this equation takes the form p is equal del f by del x plus del f by del p into dp by dx. But this is what exactly f of x, because this is going to be function of x and p, so we can say x, and this is what exactly function of p, so p and dp by dx, that is what exactly in terms of. So here, which is the first order, first degree differential equation in variable p. Now suppose we obtain its solution as g of x, p and c is equal 0. If we get the solution of this differential equation, that is g of x, p and c is equal 0. Now what we have to do? Now eliminating p from equation 1 and 3. So whatever we have the given differential equation, y is equal f of xp and here g of x, p, c, and from these two equations we eliminate p, and that is going to be what exactly required general solution. In such cases, if it is not possible to eliminate p, then the general solution can be obtained by whatever it is, equation number 1 and equation number 3. Suppose x is equal f1 pc and y is equal f2 pc. And this is what exactly parametric representation of the solution of equation number 1 in parametric p. So answer will be what in terms of p and constant, where c is the arbitrary constant. So let us see one question, then it will be more clear. Solve xp square minus 2yp plus x is equal 0. So you are given differential equation, so it is clear that we can represent y in terms of x and p. So here just take 2yp on the right hand side, so xp square plus x is equal to 2yp, so y is equal 1 divided by 2p into xp square plus x. So here what you have to do, first divide by separately. So here first differentiating with respect to, that is our main target. So dy by dx is equal p by 2 plus x by 2 dp by dx. Here we have taken product rule for the derivative, plus 1 divided by 2p, derivative of x, that is going to be 1, and then x is there, 2 is there, but 1 divided by p, so its derivative is what, minus 1 divided by p square dp by dx. But here dy by dx is nothing but p, and after just take from these two terms dp by dx common, and whatever that is the same. Here just take p by 2 on the left hand side, and then we have this one. Again just take 1 divided by 2p is that, but here I have just multiplied by 2 throughout, so what we get, p is equal x minus x divided by p square dp by dx plus 1 by p. So now just take p square as a LCM, so p raised to cube is equal x p square minus x dp by dx plus p. Now you can see that just multiply, and just if we write in simplest form, then we can take dp by p square common from first two terms, p square into p minus x dp by dx, and from this we can take minus 1 common. So in that case we can say that these two terms are what exactly common, and after that what we get, p square minus 1 is equal to 0. Now discarding the factor p minus p square minus 1. But now question is that why we are going to discarding this factor p square minus 1. If we supposed to find its solution in terms of p, then it is going to be singular solution, because the solution does not contain any arbitrary constant. So here we are eliminating this one, and what we assume that p minus x into dp by dx is equal to 0. Now using the variable separable method, we get here p barabar cx. Now what we have to do, here this from this factor we have just got the solution p is equal to 6. Now this is equation number 2 and the given equation number 1, whatever it is. After what we have to do, here p is replaced by what exactly, cx, that means solving 1 and 2. So what we get, y is equal cx square divided by 2 plus 1 divided by 2c, which is the required general solution. This is the final answer. So let us see another question. So this is the exactly given question, 2xp minus y plus p square is equal to 0. And here just make a y as a subject, then differentiating with respect to x, just take the p bar dx is equal p. Each and every step you can go through this straightforward. For our simplicity, we assume that x plus p is equal u. So 1 plus dp by dx is equal du by dx. So dp by dx is equal to u by dx minus 1. After replacing here, so what we get, 1 by 2 plus u into du by dx minus 1 is equal to 0. So here just keep in mind u into du by dx on the left hand side, and just take another on the right hand side. So 1 by 2 is there. If we put on the right hand side, it is going to be minus 1 by 2, and minus u is going to be on the right hand side, so plus u. So du by dx can be written as 2u minus 1 divided by 2u. But it is clear that variable separable method is applicable, and after integrating we get this one. But already u is replaced by what exactly, x plus p. So in that case whatever we have, so that is going to be final answer. But here I don't want here ln, so what we have to take that, we have to assume that this one on the left hand side and just take 2p on the right hand side, and that will take the exponential form, then it is going to be this one form. So here we can observe that we cannot eliminate p from the equation number 1 and 2. Okay, so this is the example equation number 2, and this is what exactly equation number 1. From this we cannot eliminate that is p, because we cannot here get here p in terms of exactly c. Okay, so therefore we can say that the general solution is what exactly parametric form. So we assume that x and y is nothing but its general solution. So today I'm just going to stop